This is section P.5. This is all about factoring. Okay, if you have had me for Algebra 2 and or pre-calculus and or both, I've told you a million times, factoring is never, ever, ever, ever going away. You will see this in every single math class that you take from now until you're done with college. I have kids that send me emails. Anybody know Jenna Perez from last year?
Yeah.
She sent me an email this summer. She said, oh my God, I love you. I just had a factoring test in my college math class and I passed it. In fact, you're right, factoring is never going away. It's not. So you just got to get over the fact that I'm not good at it or I can't do it. You guys have to get over that. So the first thing I want you to do is write down, I call this my little factoring cheat sheet. I will refer to this all the time. So I want you guys to write these things down. When you're factoring, the first thing we're going to look for is GCF. What does GCF stand for? Greatest common factor. Is there a number or a term a number or a variable that every term has in common? Then the second thing we're going to look for is a special pattern. And we'll talk a little bit about that. A lot of times we don't recognize the special patterns, and that's okay. But we'll look and see if there is a special pattern, like difference of perfect squares, something like that. Then we look and say, are there three terms? If there's three terms, that's a trinomial. All right, we're going to have a trinomial where A is 1, and we're going to have where A is greater than 1, and we'll talk about that. And then the last thing on your list you look for is, are there four terms? Well, if there's four terms, and we've already taken out the GCF, then you're going to talk about grouping. First two and the second two. All of this stuff, 100% for a fact, you guys have seen at least 2 times. You see a little bit in Algebra 1. You saw it in Algebra 2. If you were in pre-calculus already, you saw it in pre-calculus. So this is not anything new. This just may be something that you always struggled with. So we need to make sure that we're on top of it. So if I look at number 1, on my little list, what is the first thing that I told you guys to look for? GCF. Is there a GCF? Is there a number or a letter that both of these terms have that I can take out? 5. Does everybody see that? So if I take out a 5, when I say take out, I mean I'm going to divide everything by that 5. What is 5 divided by 5? 1, so I'm left with just x. And then what's negative 15 divided by 5? Negative 3. And there is your factor. You took out a common term that was in both things. Yes, sir. Okay, second thing. Guys, look. Is there a common term on the right-hand side, Hayden, like towards the bottom? Or in that black bag, there might be some paper in there. Do you guys see a parenthesis that's the same? The x minus 6. Okay, when we group, your goal is to get a parenthesis that is the same. Guys, this term and this term, there's only 2 terms in this equation, or this expression. X times x minus 6, and then 5 times x minus 6. So when we took out the 5, we took out 1 5. We took it out of both of them. Same thing happens here. We're taking out x minus 6 in both. I only write it one time. I write it one time out in front because that was the greatest common factor in both of them. Now it's gone. And whatever is left over gets its own parenthesis. What's left over? X plus 5. And we'll talk more about that in a little bit. But it's important that you guys understand, that you realize when you have a common parenthesis, you only write it one time. All right, now if I look at number 3, I go through my list. Is this a GCF? Is there a letter or a number that all 3 terms have in common? No. Is this one of our crazy special patterns? No. Is this a trinomial where A is 1? Yes. What do I mean by A is 1? There's a 1 right here in front of X. We like these. These are the ones that are a little simpler. You're looking for 2 numbers that multiply to give me negative 15, but add to give me negative 2. What are the factors of 15? What times what gives you 15? 5 and 3, 1 and 15. So I hear negative 5, positive 3. So I'm going to say, okay, negative 5, positive 3. You guys can always check to make sure. What is negative 5 times positive 3? Negative 15. Good. What's negative 5 plus 3? Negative 2. So this is correct. You always have to check to make sure your signs are right. Factoring is fun. It's like a little puzzle. All right, let's look at number 4. Is there a GCF? Is there a number or a letter that both terms have in common? No. Okay, is this a trinomial? Does it have 3 terms that we can multiply to get the last number but add to get the middle one? No. So this is probably one of our special patterns. Now, we'll get better at this the more we do, but does anybody notice anything about 9, x squared, and 25? Perfect. They're both perfect squares, aren't they? What times what gives me 9x squared? 3x and? Good. What times what will give me 25? 5 and 5. This is our difference of perfect squares. What does the word difference mean? Subtraction. So all you have to understand here, this is the difference of perfect squares. You put your terms in each. I've got 3x in the front of both of them. I have 5 at the end of both of them. And I want my signs in the middle to be different. So one of them has to be addition. One of them has to be subtraction. How could I check to make sure that I did that right? I could FOIL it. What'll happen to the middle terms? They'll cross out. Okay? All right, let's scoop. All right, factoring out common factors. Guys, let's go through our list. The first thing we always look for is GCF. Look at 3x squared and 6x. What number can I take out of both of them? A 3. What letter can I take out of both of them? An x. So I'm going to divide everything by 3x. Whatever the GCF is, guys, you write it out in front. Don't forget it. Now, 3 divided by 3 is 1. If I have x squared on top and x on the bottom, it leaves me with what? Just 1x. Good. Minus, well, what's 6 divided by 3? 2. What happens to my x's? That's it. Good. Take everything slowly, bit by bit, and you'll be okay. Look at this next one. It's long. It's got a lot of stuff in it. Who cares? What's the biggest number? What number can I take out of 8, 6, and 2? Okay, they all have at least 1, 2. I agree. Do you guys see any letters that they all have in common? X and Y. Good. How many X's can I take out? Only 1. How come? Because the last one has 1. Good. How many Y's can I take out? 2, because the smallest number is 2. Very good. Very good. So when I go and simplify, something is wrong with my iPad right there. What's 8 divided by 2? 4. Okay. What's x to the 4th divided by x? X cubed. What happens to my y squares? They cancel out. Plus, what's 6 divided by 2? 3. What? X, what? Squared. Then what? Y. Good. Then what? Y squared. Perfect. Perfect. Take your time. Look at each letter individually, each number individually. I want a positive to be okay. Right away, what jumps out? What do they have in common? They both have an x minus 3. So I'm going to divide x minus 3 out of here and out of here. So I write x minus 3 one time out in front. That's gone. What do I have left over? 2x plus 4 minus 5. Can I do anything there? That's what I have left over. The leftovers get their own parentheses. So what can I combine? What can I combine?
4 and...
So x minus 3, and then I have what? 2x minus 1. Good. Perfect. What about the last one? What do they have in common? X plus 4. Good, that's gone. Leftovers get their own, so I have what?
6x minus 7.
All right, and then how do I simplify that just a little bit? 6x, what, plus 2?
Yeah.
Okay. Anybody see anything else? Can I divide by 2 in that second parenthesis? Yeah, so I can say, I can bring out that 2, and I have x plus 4. If I divide, I have 3x plus 1. That's factored completely. If you miss that little bit, okay, couple points off, but you have to make sure. Always check and see, is there anything else? Anything else? Anything else? And you always want to simplify. 2. All right. What do you notice about all 4 of these examples? They're all trinomials. What is the first term in all of them? 1. All right, there's no GCF. We're factoring out right here where you have all trinomials. Okay, so I'm going to look and I say what multiplies to give me positive 12 and adds to give me 7. Think about the factors of 12. I have 1 and 12, 2 and 6, 3 and 4. Which combination multiplies to give me 12 but adds to give me 7? Good. So get your parentheses set up, x and x, 3 and 4. I want a positive 12 when I multiply and a positive 7 when I add. So what operation goes in? Both. Good. So again, same thing. I want a negative 8 when I multiply, when I add. Think about 8. 1 and 8, 2 and 4. So I have 1 and 8, 2 and 4, which gives me negative 8 when I multiply, but 2 when I add. Okay, I have x and x, and I have 4 and 2. Agreed? Where does the negative sign go? With where? I want my 2 to be positive when I add. So do I want it 4 minus 2 or negative 4 plus 2? Yep. It's like a little puzzle. You guys got to think. All right, this is the same question as A, isn't it? How's it different? It's a negative 7 when I add. So what are the factors of 12? Let's think. What times what is 12? 1 and 12, 2 and 6, 3 and 4. What will give me positive 12 when I multiply, but a negative 7 when I add them?
Negative 3 and negative.
Good, very good. Negative 3 and negative 4. Because a negative times a negative is a positive. Guys, here's a little trick. If the last sign is a plus, both parentheses will get whatever the middle sign is. If the last sign is a minus, then it's going to be one of each. That'll happen every time. If the last sign is a plus, the middle sign goes in each parenthesis. Look, the last sign is a what? The last sign is a what? It's a minus. That means one's going to be plus, one's going to be minus. I need the factors of 8 that multiply to give me negative 8, but add to give me negative 2.
Negative 4 and positive.
Good. Negative 4, positive 2. Where you put the numbers matters because you have to have your signs right. So do you see how A and B and C and D, same factors, but the signs are different? That's what you guys have to pay attention to. All right, how many terms are here? 4. Obviously, it tells you what to do, but I told you to go through the list, GCF first, because on your quiz, on your test, I'm just going to give you problems to say factor. I'm not going to tell you factor by whatever. You guys have to do it. So run through your list. Is there a number or a letter in letter A that every single term has in common? No. Is this a trinomial? No. Is this a special pattern? No. This is 4 terms, so we group. You group the first 2 and you group the second 2. Notice that I put the sign, that's what that third term, goes with your grouping. So make sure you do that. So now I look at each parenthesis separately. Which letter or number in the first parenthesis do I have in common?
X squared.
X squared. Good. I can take out x squared from both of those. So take out x squared and x squared. What does that leave me with? X plus,
That's it.
nope. Anything divided by itself is? 1. Okay? Guys, this is a hint. That x plus 1 is a hint. What do you think the other parenthesis is going to look like when I factor something out? X plus 1, because we're trying to find something in common. So look between 4x and 4. What can I take out? Positive 4. Good. So when I do that, take out 4. What am I left with? X plus 1. Perfect. Now, do you guys see something in common that I can divide out of both? Do you see a parenthesis that they have in common? The x plus 1. Good. So I'm going to take out this x plus 1 and this one. I'm going to rewrite it one time out in front. And then what happens with my leftovers? They get their own. Good. Now, we always have to look. Can I factor any more? I see x squared plus 4. Is that the difference of perfect squares? Is that the difference of perfect squares? X squared is a perfect square. 4 is a perfect square. But is it the difference? Yes or no, guys? Difference means what sign? It's not the difference. Difference means subtraction. That is as factored as you can make it. If it was, it's not, but if it was x squared minus 4, what could you break that down into? X plus 2, good, Hayden, and x minus 2. But it's not. So that's not true right now. If it was minus, if it's perfect squares on either side and there's a difference, you can do that. Okay, let's look over here. This is really important. You guys pay attention to this one. How many terms? 4. That means we have to do what? Group. So I'm going to group the first 2 and the second 2. Notice what I kept in the second parenthesis. That negative. That's important. You guys have to make sure that you do that. So, what do I have in common, Bye, William? Have a good weekend, bud. What do you guys have in common at first parenthesis? X squared. Okay, good. I'm going to take out the x squared, and I'll be left with what? X minus 2. Agreed? Okay, what can I take out of the second parenthesis? Negative. Do you see how it leads with a negative? Take the negative out. So when I divide by negative 3, I get x. What's 6 divided by negative 3? Negative 2. Do you guys see how, since I took out that negative, now my 2 parentheses are the same? Here and here? If you didn't take out that negative, you would have been left with negative x plus 3. So make sure if that third term is negative, you take a negative out. So what do they have in common that I can write one time out in front? X minus 2. Awesome. And then what happens to my leftovers? X squared minus 3. They get their own parenthesis. So on your quiz on Wednesday, literally, maybe 5 questions, 6 questions, I don't know, we'll see. But I'm just going to give you questions. I'm going to say factor. Some are going to be GCF. Some are going to be a trinomial. Some are going to be grouping. It's going to be all of this stuff that you guys have seen a million times, and we're just going to practice. That's what we're doing Monday and Tuesday. Practice, 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 practice. I love to practice. Okay, what do you guys notice? Yeah. How many terms are there? 4. First thing I want you to look at, though, is what? It's the first thing we always look for when we're factoring. There's a common factor. Is there a number or a letter that all 4 of these have? 2. So let's factor out a 2. I'm going to take a 2 out. I'm going to make our numbers smaller. We like that. So I'm left with 3x cubed plus 2x squared plus 6x plus 4. You guys agree? Yeah? Okay, so now we still have that 2. It stays out in front. I have how many terms? 4. So that means what do? Group. First 2, second 2. What can I take out of this first green parenthesis?
X squared.
Okay, so I'm going to take out x squared. What am I left with? 3x. What? Plus 2. Awesome, Ryan. In the second parenthesis, what can I take out? Okay, if I take out a 2, it's a positive 2. What am I left with? What's 6x divided by 2? 3x plus 2. Did that work out how we liked it to? What parenthesis is in common? 3x plus 2. So guys, we already have a 2 out in front. Leave it. What's the common parenthesis? 3x plus 2. And then what happens with our leftovers? It gets its own parenthesis, right? That's it. Now some of you are going to say, do I have to multiply that back together? No. Because if I multiplied it back together, I would get this original. When we factor, you want to make things simple. You want to pull it apart. Yes, ma'am?
If you didn't took the 2 out first, you got 2x squared plus 2 and then times.
Okay, so Alexis left it like this, and she got 2x squared plus 2 with what else? 3x plus 2. Okay, that's fine. But then there's one more step. Do you see a common factor that you can take out?
The x times Wait, I thought.
Wait. Do you see a common factor in either parenthesis that you can take out? Yep. So you would take it out at that point, and you'd say x squared plus 2, which you got the same answer, right?
Miss Mel, shouldn't it be 2x squared plus 4? Not plus 2.
Why?
For the, how Alexa said it. Because I did it that way.
Oh, here.
2x plus 4.
Yeah, and then you just take out, yeah. But you see how it doesn't matter. That's a very good point. It doesn't matter. If you miss the GCF at the beginning, you can always get it out at the end. I just try and stress that you guys always look for GCF first, because then it just makes your number smaller, which we like smaller numbers. Okay, same thing here. Is there a letter or a number in all 4 that you can take out? No. So I'm going to group because I have 4 terms. Notice that I kept that negative sign with the 12. See that? Yes? All right, so what can I take out of 8x cubed and negative 2x squared?
Negative 2x squared.
Don't take out a negative, because if you do, then this becomes negative. If you lead with a positive, leave it positive. But what number and letter can I take out of both? 2x squared. So when I do, I'm left with x, what?
Is it 2x or 4?
4x. If I divide out 2x squared, guys. Minus 1. Good. Thank you. Now, look, I lead with a negative. Val, if you lead with a negative, that's where we want to take out our negative. What goes into both negative 12 and 3? What kind of 3? Negative. Take out that negative. Good, Josh. So if I take out, look, if I divide by a negative 3, negative divided by a negative is a positive. Negative and a positive is a negative. Now do you see how both those parentheses are the same? Take it out, write it one time, 4x minus 1, that's your GCF. Now it's gone. And what happens to my leftovers? They get what? Their own parentheses. So this is 2x minus 3. Good. Good. Moving on. Factoring trinomials where a is not 1. Okay, this is where this gets a little yucky. We don't like these ones. There is a bunch of different ways to do this. I'm going to show you how I think is the easiest way. You guys do what you want. But do you see how this term, a, the number in front of x squared, is not 1? Everybody see that? So we're going to first thing we're going to do is a times c. So I'm going to say 4 times 15. What is 4 times 15? 60. Okay, these numbers get a little bigger. I know that's a little frightening for some of us, but that's okay. Now let's think of our factors of 60. 1 times 60, 2 and 30, 3 and what? 3 and 20, obviously 4 and 15, 5 and 12, 6 and 10, right? 11, 12, okay, we're good. So I am looking for numbers that are going to multiply to give me 60, but add to give me positive 23. Look on my list.
3 and 20.
3 and 20. Good. So that's what I want. So watch. This is what I suggest that you do. In front of each parenthesis, write the a term. Write the 4x. Write the 5x. Whatever it is. But write it.
You know the square part?
Don't worry about that. I'll show you. Then I'm going to write my numbers, 3 and 20. Okay, so what happens with our signs? I want positive, positive, yes? Remember I told you if the last thing is positive, the middle sign goes in both, so it's plus, plus. Everybody good? Okay, look at each parenthesis. Is there a GCF? Is there a number I can divide out of 4x plus 3? So just leave 4x plus 3. Is there a GCF? Is there a number I can take out of 4x and 20? Yep. So this becomes what? X plus 5. I'll show you a different way to do it. How can I check to make sure I did that right? I could FOIL it back. You could also do it this way. Look, you could start each of your parentheses like this. X plus 3, x plus 20, right? You guys agree 20 and 3 is 60 and 23? Now you could divide everything by the a term. Does 3 divide by 4 nice and pretty? No, so that becomes your coefficient, 4x plus 3. Does 20 divide by 4 nice and pretty?
Yeah.
What does it become?
5.
X plus 5. Same thing. You guys see how I did that 2 different ways? You can either put the A term in the front of each and then take out the GCF, or you can put the A term underneath each and then divide. It's the same exact thing. Either way will work. It's one extra step. Let's look at this. Is A, the number in front, 1? That means I have to do what? A times C. Guys, I'm not going to give you any numbers that are massive because you don't have a calculator. But write out your factors of 40. 1 and 40. 2 and 20. 3? No. 4 and 10. Obviously 5 and 8. And then that's it, right? So I'm trying to find things that multiply to give me 40, but add to give me negative 14. Well, look at your list. Which one could I get 14 from?
4 and 10.
4 and 10. Good. So let's do it both ways. I'm going to write 5x in the front of both. Now look at this sign is a plus. That means both parentheses get the middle sign. So which is what? Minus minus. So 4 and 10. Can I factor anything out of 5x minus 4? Nope. Can I factor anything out of 5 and 10? Yeah, if I divide both by 5, I get what? X minus 2. You could also write it like this. Just the x in the front, minus 4 and x minus 10. And then what did I tell you to do with the A term? Where do you write it? Well, not yet. Where do I write it first? Underneath in the denominator. So now I say, does 4 divide by 5 pretty? Nope, kick it out front. 5x minus 4. Does 10 divided by 5 pretty? Yeah, x minus 2. Same thing? Yes? Just 2 ways to look at it. We have time. Doing what?
20.
Uh-oh. GCF? No. Special pattern? No. 4 terms? No. What do you notice? It's a trinomial, but A is not what? Multiply A and C. What's 6 times negative 5? Negative 30. Write your factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. I'm looking for factors of negative 30 that will multiply to give me negative 30, but add to give me 7. Which one up there will give me 7 somehow?
Negative
3 and 10. Good. Evan, you are on this. 3 and 10. Do you guys agree with me that negative 3 and a positive 10 multiply to give you negative 30, but negative 3 plus 10 gives you 7? All right, so you can write either way you want to do it. You can put 6x in the front of each of them. Can I take anything out of 6x minus 3?
Yeah.
A 2, right? If I factor out a 2, I'm left with what? I don't know why I just did that. It should be 2, yeah.
Yeah.
My bad. Come back. We're going to take out a 3, right? Yeah, I know what you meant. So 2x minus 1. And then what can I take out of 6 and 10? Take out a 2. And I'm left with 3x plus 5. You do it the other way. Like I told you, you could say x minus 3 and x plus 10. And then the 6 underneath both. So simplify that. That becomes x minus 1/2. Agreed? X minus 5 over 3, or plus 5 over 3. And then what do I do with my denominators? Kick them out in front. 2x minus 1 and 3x plus 5. Same thing. These are the ones that you guys are going to need the most practice on, which is fine. We have 2 days next week to just practice. And I'm going to make you practice. You're welcome. You'll thank me later. All right, here we go. We're going to do this one fast because we know how to do it. A is not 1, so I'm going to multiply A times C, and I get negative 30 again. Well, awesome. So I already know the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now I'm trying to find factors that will give me negative 30 when I multiply, but a negative 7 when I add. What do those happen to be? 3 and 10 again. But what are my signs? Negative 10, positive 3. So again, put the 2 in the front. Can I simplify anything with 2x plus 3? So that stays as 2x plus 3. Can I simplify anything with 2x minus 10? Yep, divide both of them by what? 2. And I'm left with x minus 5. Great. God bless. It's like a puzzle. Okay. Now this is how your quiz is going to look. Factor it. So the first thing we say is what? Is there a GCF? No. Then I say, is this a special pattern? No. Then I say, how many terms is it? 3. So it's a trinomial. What do I know about this trinomial? Is A 1 or is A bigger than 1? A is 1. So this is easy. What times what gives me a negative 3 when I multiply, but a negative 2 when I add? Negative 3, positive 1. Good. Okay, second one. All right, I want to get to some of these patterns. Like I talked to you guys about earlier, difference of perfect squares. Look, that's when we have 2 parentheses that are exactly the same. Do you see this? Exactly the same. But what's different? The signs. Or if you start off and you recognize that you have a perfect square and there is a minus sign in front of it. That's important. You're also going to have areas where it's perfect squares where there's a plus sign. It's not the difference. You're not going to have 1 minus 1 plus. You're going to use this pattern here. And we'll talk about that in a second. And then the perfect cube. So let's go to some of these. Okay. Special patterns. Let's talk about these. Are all going to be special patterns. What do you guys notice? There's no GCF. It's not a trinomial. What do you notice about 4x squared and 25? They're both perfect squares, right? Is this the difference of perfect squares? Yes. So that means you say, okay, well, what times what gives me the front? What times what gives me the back? What times what gives me 4x squared? 2x and 2x. What times what gives me 25? 5 and 5. So just plug those in. And then if it's the difference of perfect squares, what do you know that the signs are? The same or different? Good. Guys, with these, you can always check, because what can you do to make sure that you did that right? Foil it. This one's a little harder to see. It's a little harder to see, but are these both perfect squares? How do you know they're perfect squares? Because it's squared. So this one would be x plus y and x plus y. This one would be what? Z and z. Is this the difference? Yeah. Yes. So your first parenthesis would be x plus y plus z minus x plus y. What?
Minus.
Don't get hung up on those right now. Don't get hung up on those. Let's look at C. Just focus on C. What do you notice? Hi. What do you notice? How do you know it's the difference, guys, of perfect squares? There's a minus sign. And you notice that 9x squared and 16 are perfect squares. So just tell yourself, what times what gives me 9x squared? 3x and 3x. Good. What times what is 16? 4 and 4. So 3x goes in the front, 4 goes in the back, and what happens to my signs? Plus and minus. Good. And again, how can I check? Multiply. Foil it out. Good. All right, these are a little different. You can factor these like normal. You don't have to recognize that it's a special pattern. This is a special pattern, but you don't have to recognize it right away. If you don't, no big deal. A is 1, correct? So figure out what times what gives me 9 when I multiply, but a 6 when I add. 3 and 3. And what are both of the signs? They're both positive. So you would write this as x plus 3 squared. It's a perfect squared trinomial. If it was x squared minus 9, it would be x plus 3, x minus 3. You guys see the difference here? If this said x squared minus 9, your answer would be x plus 3, x minus 3. But since the sign is the same, it's going to be a perfect square trinomial.
For the test quiz, either it can.
But you guys will see it written like that. What about here? Okay, you may not notice right away that this is a perfect square. No big deal. A is 1. So what times what gives me 16 when I multiply, but a negative 8 when I add? Negative 4, negative 4. The parentheses are the same. How can I write that? X minus 4 quantity squared. Couple more. You guys are doing good. All right, what about here? What's my parentheses look like?
X plus 2, x minus 2, x plus.
Okay, I like that you said that. Do you guys see the difference? Yes or no?
Yes.
In these two problems. This is the difference of perfect squares. When you FOIL that out, when you have the same parentheses but different signs, the middle terms cancel out. When you have a perfect trinomial, you'll have the same signs, and what you're doing is doubling that middle term. Do you see how you have 2 and 2 is 4? Or you're dividing it by 2, however you want to look at it. Depends on which way you're going. Okay, this is a little harder. It's not a perfect square. It's considered a perfect cube. We'll end on this one. The perfect cube formula is down here. Okay, you guys, you're going to need to know how to do this. And again, next week, I promise we'll practice. But this is the perfect cube. It's the sum. So look at the formula for the sum. You have A and B, all right? What is my A term? What times itself 3 times gives me A to the 6th power? I mean, X to the 6th, whatever. X what?
Times x times x times x times.
But what times itself 3 times? X squared. Who said that? Good, very good. If I have x squared, look, and I cube it, what does that become? Right? Okay,
Wouldn't
good.
it be 5 though? I thought you had to add them.
No, when you have a power to a power, you multiply. And you guys already know this. What times itself 3 times gives you 8? 2. Okay, so all you do now is just take the pattern and you fill it in. This is the plus, right? Difference. It's a sum of cubes. So fill in your pattern. What does my first parenthesis look like? What's my A term? What's my B term? X squared. Keep going, Christian. What's my B term?
Plus 2.
Perfect. Now look at the second parenthesis. What do I do to A?
X squared minus.
No. What do I do right here?
Under parentheses.
It's my x squared, but what do I do to it?
To the 3rd power.
What do I do to it? What's circled?
Oh.
Squared, right?
Squared.
So we're going to square it. Just follow the pattern. Then it says minus A times B. So what's my A? What's my B?
X squared, xb squared.
X squared times 2.
Yeah.
And then plus my B squared. What's B?
2 squared.
And I square it. Good. And then you just simplify. So you have x squared plus 2. And we'll go over this more, I promise. When I have a power raised to a power, Ryan, what do?
Multiply.
Perfect. Guys, what is 2 times x squared?
2x to the 4th.
Nope. Just 2x squared. Just put it together. And then what's 2 squared? 4.
Oh, you said 2 times x?
Yeah, that's okay.
I don't think about that.
That's okay. Again, we'll practice this more. I promise. We'll practice this more on Monday. But look at it. I just want to do the second one. Let's do B. This is a perfect cube. What times itself 3 times will give me 27? 3. Good. What times itself 3 times will give me x cubed? X. Good. What times itself 3 times will give me 1? 1. Perfect. Now we follow the pattern. This is the difference of perfect cubes. So the first parenthesis should be what? A minus B. So literally write down the A term
3x
minus the B term. Good. Now I look at the rest of the pattern. A squared plus AB plus B squared. So A squared
3x squared.
would be, watch, 3x squared, right? Plus, what do I do? AB. So my A is 3x, my B is 1, plus B squared. 1 squared. Here's the tricky part with this, guys. 3x squared is what? For $1 million.
9x.
No, look at you. You're a millionaire. Have a good weekend. What's 3x times 1?
How come it's squared?
Say it again.
How come 9x is still squared?
Because, oh, why did I write that?
Yeah, that's
Because look, you have the squared goes here and the squared goes here.
Oh,
And then what's 3x times 1?
3x.
3x.
And then what's 1 times 1?
1.
There you go.
This one was from the rest of you, the problem.
If you guys know the pattern, this is super easy. If you don't know the pattern, it's hard.
So the first one you write, like A minus B, it stays the same always.
The formula is what is a little tricky. But that is it.